Well, let me see somebody's notes. I want to make sure I don't repeat myself. I think the last thing I covered was, probability. Yeah, we were talking about correlation. Okay, so I didn't go into probability yet. I might have said a few things about it. Now, all y'all know pretty much where Wild Hog Road is. Did we talk about Wild Hog Road?
Yes.
We did, and the blue layer? Okay, well, I don't have to worry about that. Did we talk about probability as far as theoretical versus physical? Yes. Or Mayberry? Did we talk about that?
Yes.
All right. Did we talk about being from 0 to 1 in the complements? Okay, I think that's all where I ended. All right. So, in probability, you have two sides to every coin. You have two sides to every sword. The probability of an event happening and the probability of the event what? Not happening. Now, this is the way Hubert does it. All right. You got, was OJ innocent or was he not guilty? Anybody want to take a stab at it?
Not guilty.
He was not guilty. Nobody said innocent, did they? Why? Because OJ was not innocent. Okay? OJ had something to do with that murder. He might have had it paid to be done. He might have helped with it, or he might have did it all himself. But he had something to do with that murder. All right. Now, why do I say that? Well, let's say Miss Zug works at Papa John's Pizza, okay? And she has an apartment in Anderson, and she has 2 roommates or 3 roommates or whatever. I don't know how many roommates you have to have now to have an apartment. But anyway, she's got a roommate that's pretty much a sandbagger. In other words, he don't pull his weight, or she don't pull her weight, or whatever the case may be. She ain't got no car. She ain't got no job. All she does is sit around and play freaking video games all freaking day. All right, you know the type. Anyway, so she goes to work every day after school. She goes to school till 2 o'clock in the afternoon, and she works from 2 to 11 just about every day. Well, one Friday night, her roommate, he or she or whoever it is, says, "I need to borrow your car." Okay, well, take me to work and you can borrow my car. Okay, so she lets her roommate borrow the car, and while she's at work, the slacker, roommate, goes off and robs the Waffle House on the west side of Anderson, which normally happens every month. So anyway, the next week, here comes the Popo. They come in and they take Miss Zug away. Will Miss Zug ever see the courtroom?
No.
Why?
Because she was at work.
Yeah, but how you gonna prove it?
Clocked in.
It's clocked in. How else can she prove it? What will Papa John's probably have?
Security footage.
Cameras. And the last and most reliable is the what? People she what? Works with. She is completely 100% what? Innocent. She will never see the courtroom unless her lawyer is not worth a flip. Okay? She will never see the courtroom because she's innocent. Innocent people don't go to court. Okay? Why did OJ go to court? Anybody, people in here that ever follow the OJ case? Why did he go to court? If he was innocent, why did he go to court? Because he could not prove what? Where he was. Now, if you can't prove where you are when a major crime is happening and your evidence is there, or some of your evidence is there, or whatever the case may be, then what are you? Are you innocent, or you're innocent until proven guilty? You're innocent until proven guilty. You're going to be in a courtroom. And that's what a whole arraignment is for. Okay? So, does the innocent get tried? No. Usually they do not. The not so innocent, that's a different story. Okay? That's the difference between innocent and not guilty. Just like not an event happening. Now, Of course, that's not the way. This would be the most common way to write a non-event, but you got to write it this way. Okay? Can somebody tell me what these are to each other? Now, I don't know how they spell complement. I think it's spelled with an I, but y'all can look in the book. I can't remember. But the complement is what makes up the whole. There is 30 students in this classroom. 28, 32, somewhere in there. I'm going to say 30. Over on this side of the room, 2, 4, 6, 8, 9. We have, I'll be 10. We have 10 people. How many is on this side of it? 20. Why? Because 10 is complement to 20 when the total is 30. See what I'm saying? So the complement is what makes up the whole. You need to write that down. What makes up the whole? That's the easiest way to explain a complement. Now you can have a complement several different ways. Okay? If n is 30, and what is the probability of people being on the right side of the room, my right, stage left, whatever, stage right, whatever. I'm going to say left. Okay? Being on the left side of the room is 10. Therefore, the probability of not left is what? 20. Now, you can do it with quantity, you can do it with percentage, and you can do it with probability. Now, probability is usually written in decimal form. Write that down if I haven't told you that. Because some teachers with no wife, girlfriend, boyfriend, whatever, they have a conniption if you walk into a probability and statistics classroom and say 50% probability, they'll have a cow. It's like saying ain't in English class. Okay? Some of them go into what do you call them? Convulsions. All right? I don't really care. But when you start talking about percent, you're talking about chance. When you talk about probability, you talk about the decimal form. Does it matter in here? No. But does it matter to some teachers with no life? Yes. You can do it with percentages, quantity, percentage, or probability. So if n is equal to 30, probability of left is 10, then the probability of not left is 20. If the percentage is 100 and the probability of left, I'm just going to make up is 30%, then the probability of not left is what? 70%. And so on. It works the same way. The only difference between probability and percentage is that's a 1, and then this would be like in cents. So probability of left would be 0.2. The probability of not left is equal to 0.8. Now, somebody tell me why I don't say right. Well, that's another little technicality of probability. Some people do not. And probability, there's some things that you do not say the alternative. You say the complement. Okay? For instance, write roulette wheel question. Write that down. You're going to see the roulette wheel. Probably not today, but you might see it in the near future. I know you'll see it on the test. Roulette is R-O-U-L-L-E-T-T-E, I think. I don't know. Y'all just spell it the best way you can. This ain't dadgum English class. All right? The roulette wheel says there's 36 slots. No, there's 40 slots on a roulette wheel. Okay? 19 are even. 19 are odd. And 2 are neither. And if you know a roulette wheel has half red, half black, and 2 what color? Anybody know? Green. 2 greens. Okay? The 2 greens are 0 and double what? Double 0. They're neither odd or even. Now the question is, what is the probability of your marble laying on an even number? Okay? Now, the alternative to the even is the odd, right? But would that incorporate all of the slots? No. It would only incorporate the odd slots. And there's 2 slots left over, which is the green slots. So instead of using the alternative, which is odd, you would use the complement, which is not what? Not even. That's the difference. Kind of a fine hair between innocent and not guilty. You see what I'm saying? So there's an alternative and then there's a complement. Always go with the complement. Write that down. Always go with the complement. Such true false. The alternative of true is false. But what's the complement of true? Not true. Okay? And some of y'all may say, well, that's the same thing. Well, not always. And I think I've proven that with innocent versus not guilty. All right? Now, we're going to do a little bit of experimenting with the Mayberry before I go into the large number rule and before I go into odds against. We're going to do a little experiment. I want each of you, each group, to have a shuffler. Now, when I say a shuffler, okay, some of y'all don't know how to shuffle. Okay? If you don't have any idea how to shuffle, do not touch the cards, okay? Because I don't want you, this is the way, let me get that card. The other day I was doing a class, and I'm not going to say which class it is, and there was a couple of students shuffling. Oh, who did this? This is so, don't you hate people that turn cards around? Same thing with money. I can't stand when money, the president's head's facing the other. Oh, I can't stand that. Yes, OCD, maybe not all, okay? But I don't want to mess this deck of cards up for y'all. Make sure all the directions, I think somebody took all of them, threw them away because I don't see them. There's always a direction card, but anyway, this is the way they were shuffling. Okay, that's not it. That's half-ass, all right? If you don't know how to shuffle, do not touch the cards. Let somebody that does. Of course, we know all the shufflers up here because they're all guys and they know how to do everything, right? We got a few guys back here, but not really enough, so we might have to stretch these professionals out. Because you know they'll be professional no matter if they know how to shuffle cards or not. Yeah, I know where I'm going. Yeah. Didn't we pass this store like 3 times? Yeah, I know how to put this bike together. I do it and I don't need directions. The little boy gets on it and ends up in a ditch with a broke arm because the dang wheel falls off.
That ball was defective.
Yeah, you take out the jokers. Take out Big Mo and Little Mo. There, and take out that one. Take out, there it is. If I tried to do that in Vegas, I just cut this deck and the thing I was trying to find, there it is. If I could do that in Vegas, I'd be a millionaire. Anyway, take that one out. Take the YouTube card out and take the instruction card. I think those are the only 2. Take the Big Mo and the Little Mo out. You should have 52 cards after that. Big Mo is the Joker, the Little Mo is the Little Joker. Some of y'all have no idea what I just said, but anyway. Okay, y'all can do the rest. Okay, there'll be one recorder. That's the person who writes down the results. And then there'll be one person to roll the die. Okay? You're going to do three rolls, three trials with the cards and 3 trials with the die. Trials equal 10 shuffles, 10 rolls. So you talk about 30 times. Okay? Now, what are you going to do? Well, that's up to the group. But I tell students this is kind of what I would do. I would pick something. Say like pick the first by yourself. Pick anything. All right? And I'm going to pick, just for me, I'm going to say the probability of picking a king. All right? Now, the first thing you do is you say, okay, the Mayberry probability is 4 out of what? 52, which is 1 out of 13. All right? And that comes out to be 0.13 or 0.07 or whatever. Put the decimal down. Go ahead and do the figures of the Mayberry probability. Then you will shuffle. One person picks. Write it down. Shuffle. One person picks. Write it down. Shuffle. One person picks. Write it down. If y'all want to cut between, if you want to cut and shuffle, do that. It's better to mix it up. The more the better. All right? After you do the first 10, figure up the physical probability. Oh, well, we got 2 kings, so that would be 2 out of 10, which is equal to 0.2. All right, that's the first trial. And then you say, well, golly, we had a lot of 7s show up. Okay? Or we had a lot of odd numbers showed up. Okay? So then you say, in this first trial, we had a lot of odd numbers, so let's do odds. And this is just something that you can do. Okay? Do not do odd and. Don't do that. No, this is not, we haven't got that far yet. All right? That's 2 sections down. Just one thing. One. Not black or red. Not red and black. Not king and queen. The other class messed that up. So please, don't do that. Some of y'all can break a handle with a banana. All right? So just do one thing. So this is just something I told the other class. Since I got a lot of odds that showed up in this one, I'm going to see what happens when I do odd. And then I do shuffle, 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 and then I write down, okay, 3 times I got an odd number. Now, what does odd mean? Odd means that face cards are worth what? 10, and aces are worth 1 or what? 11, so they're odd. Okay, you got to remember that if you don't know anything about cards. And you write down, okay, I got 3, 2, or 3, ace, and 7. I got 3 out of 10. Okay, so I got 3 out of 10, which is equal to 0.3. And you also need to figure out the Mayberry probability. Odd would be ace, 3, 5, 7, 9, right? Make sure I did that right. And then, is that it? I think that's it. 5 times what? 5 times 4 is 20. So that'd be 20 over 52. Somebody check my math. 20 over 52. And you figure that probability, that's your Mayberry probability. And then let's say that you showed up that there was a lot of even numbers or a lot of reds in that last draw. Then you might say, okay, well let's do probability of a red card. And you don't have to do this. This is just an idea. And then you shuffle, pick, shuffle, pick, shuffle, pick. Make sure you record everything, okay? And you calculate everything, and we're going to see what happens at the end of this little project, okay? Now, with the die, you're going to do the same thing. You're going to pick something initially. Probability of a 6. You roll 10 times. Now, if you want to roll 20 times, that's fine, but 10 is fine because it's easy math. Record every single thing. Probability of a 10 is 0.16. I mean, probability of any number on the die is 0.16. You're going to roll it, and you're going to do the physical probability, which comes out to be, I got 2 out of 10, which is 0.2. Okay? So get started. You got a few minutes to do that. There's a reason I'm doing it. I'm not doing it just to take up time. Let me see what time it is right now. Miss Niece, you can just go back to sleep. All right, 8:30. I'll give y'all 8 minutes. 8 minutes. So don't talk, just do it. I mean, you can talk about everything else. Is there 3 cards in there or 2? No, it should be 4. There's a YouTube card, there's a instruction card, and then there's 2 jokers. So check and make sure you don't have any crazy cards in there. Try not to break the die.
When you get 5?
That's up to the group, whatever the group wants to pick. But remember, just pick one thing. Okay, y'all don't get 5. Good God.
We get it.
5, 10.
5 was regular. 5 was diamonds, queen, 10 was spades, queen was clubs. 10 was spades. Or they can hide.
You gotta put them back.
Okay.
Yeah, you gotta put them back in the deck. After you draw, you gotta put them back in the deck, and you gotta.
Yeah, our probability. What we're doing now is just Is that the second time he's got it? Yeah, but it was hard. Oh, that was close. One more time, yeah.
Don't be bending the card. Then don't be breaking out the Marlboros, okay? I don't want to do that in here. Especially the Marlboro Red.
And there's 3, there's 4 different suits as well.
No, that is hard. I thought it was 0. I was like.
Figure out the here.
Probability of getting
Yeah, you can round, my friend. Whereas our probability works a lot.
I mean, actually, you never watched Sesame Street or whatever? Yeah.
Alright, you're doing the die now.
No yawning. I saw that.
We got a lot of reds.
See, that's why you're going to end up losing big.
So what are we doing? Let's do 7. Probability is getting.
My daughter told her first grade teacher that she was going to be a failure.
Alright, let's go for it. Probability of getting 4.
I thought I was serious.
4? Okay, I got this. 1. .16. Yeah, and ours was .2. This is probably even number from this and even number. Yeah, 1, 6, 5. You didn't even write one out. That's a dot. That's a dot. It's a 1. It's a 1. 5, 1, 4, 3, 5, 4, 18, 2. She wrote it. That took her a second to register. There's no 7 on that. They're only wait.
I'd have an email before I got back from home. Yeah, right. There's always one. There's always one. Yeah, I really don't think I'm getting my money's worth. He just hit the class the other day.
You were only getting today.
So we got to do jury trials.
I gotta go to the
We have to do jury trials, which is 10
Good job, Jake. Good job. Pick it up. You're the one that dropped it. You get to pick it up. It's behind you. It's What is it, Rich? It's literally under you.
All right, y'all finished?
Oh, slackers.
How's the professional gamblers up here doing?
Pretty good.
Actually, she's the only one that can shuffle.
That's your second one. Keep the count. Okay, y'all about finished?
I really did. And yours obviously
Y'all finished?
dealt it.
Yeah, no, yeah. Oh, you finished with the die, way to go. How's this group doing? Y'all
Look, dang,
Look
come
on,
on,
that
that's
spreadsheet over here.
I think that's her. I actually got him to believe it. Gee, I know Gary.
And he wrote it down on This is no joke. I've been doing this project, this little thing right here, for about 4 or 5 years. I said something about it in one of our department meetings the other day, and I thought those other math teachers were scared. I'm like, God, it's in the book.
Or he takes cut. He's angry all the time. He's made of iron and willpower. I told you, yeah, cut it.
Oh, I see why now. Yeah, y'all about finished, aren't you? Well, hurry up.
We wanna do honors.
Hey, gum, y'all dragging this out. I know why you're dragging it out. You don't want to do nothing else.
Last time.
What are we gonna talk about?
Probability of pain, probability Look what you did.
What did it land on? 8.
So how many cards are? Okay, 5. 4. 3. 4. 1. 6. 3. 3. Keep going. 6. You got it.
Hey, wait.
Pick it up, Jay. Yeah.
Are y'all finished now?
Well, it looks like she's got a half a page there. She should have all of
No,
them.
That's
that's
an
yours.
example. We got that one pretty good. That's 1.5.
Oh, yeah, mercy. I didn't think this was building the rocket.
What are we doing? Odd cards?
What do y'all, number 1?
Well, that's not.
45, 19, 18, 19.
How did you do Y'all on your last one?
Well, you should be doing, you two should be doing the dive.
Oh, okay, I thought y'all had.
We have to do one more.
Well, let's just know.
Let's
just assume it's happening now. 1, 3, 5, 7, 9.
Actually.
I know, I'm sorry.
How's the short bus through?
Found out.
Y'all went from the professionals to the short bus crew.
No, you just have to move as much as
Oh, good job. He found the joke,
Oh my.
I said short bus in one class and one person. I'm offended. Well, I wrote a short bus for 2 weeks, so. I was in 2nd grade, they put me on the short bus.
Oh, Ray L.
My mama went up there, there's all kinds of things. Nothing wrong with these boys. Country. I had to go see I had to go over to the guidance counselor every week for 2 weeks to see a puppet.
Stop trying to guess.
Google it, his name is Duso, D-U-S-O, Duso Salt. Still remember that. It's something, working with others, and it happened right after I called the checker last.
Whenever he picks, just let him choose.
This is our first case.
I don't know.
Y'all are letting the Russians do the toll. He's gonna mess them up.
Hey, I'm the one who puts the numbers in that computer.
Yeah, you're the one that changes the votes. All right, finish up, because somebody will complain if we take too long. Yes, we took a whole 45 minutes to do a project the other day in class.
Try the numbers, how about that? 5, 1, 2, 4, 5.
Now, when you really see chaotic theory, it's with the die. Does anybody know what chaotic theory is? Nobody? Yeah, it has to do with chaos. Well, I tell you, there's no getting over on y'all, I tell you. You can take this die, and it is is everybody listening? Okay, y'all can write and look at the same time. All right? This die should be, what do you call it? Non-partial. And if you have let's say you have a shelf right here at a 45-degree angle, and you put that die on 2 every single time, and you put it at the same spot on that solid shelf, and you just let it go. It's over there. Roll 5. Put it back on 2. You see what chaotic theory is? You can control all the parameters, but the chaos still goes over there, goes over there. Do it one more time just so you can see it. 2. It rolled 1, but it rolled 1 in the other direction. You cannot predict the random chaos of a die unless you do what to it? You load it. Okay? Meaning that you drill a hole in it, maybe on this end right here with the 6. Drill a hole in there and stick a piece of what? Lead, metal, and then put what under the table? Okay? Of course, you get beat up with a guy in the back alley of the Las Vegas casino with rings all over his fingers, but that's how you load it. Because what will happen is you have put something in the die to lessen the randomness. I didn't say predicted, I said lessen. Right? And it will fall on this end most of the time. Okay? Then take some paint, put some black paint in there, nobody will ever tell it. Okay? Does it have to be a lot of weight? No. It can only be like a pencil lead. It could be just a lead pencil lead. It could be as thick as a coat hanger. Put it in there. Okay? But it's enough to throw the balance off to where it's on that right there. It'll fall close to that 6 every time or whatever. Okay? All right? That's called chaotic theory and randomness. But you see it with this because some of you look at your first row of numbers with the die. Is there a number that shows up a lot? Yeah. And then you think to yourself, well, heck, next time I roll this die, I'm going to hit 6s. Because 6 showed up a lot. And then what happens when you do that? You catching on, okay? That's why I wanted you to do that. And that's called the chaotic randomness. It's shown with a die more than the cards. Because cards, why are the cards more predictable than the die? Because the die lands on its edges. The cards land on one edge. I mean, there's not a lot of chaotic. There's not a lot of chaos in cards, but the randomness is there. Okay, now let's take the short bus gamblers up here. All right, let's go with your first. I'm not going to try to go through all of them because I have no idea what time. I got 3 screens up here, and I don't have a clock on either one of them because they're covered up. What time is it? Okay, we got time. All right. Let's see. 8 to. Okay, yeah, we'll do it. All right, so let's go with this group. What was your first card prediction?
The probability
Against the what?
of face.
Okay, so what was that Mayberry probability? The Mayberry probability is equal to what?
0.2307.
0.23. Which is face card is 12 out of 52. Somebody check my math.
Right.
Okay, how many times in that first run of 10 did you get a face card?
1 out of 10.
1 out of 10 physical probability, which is equal to 0.1. Equal or not equal? Not equal. All right. What was your second run? Did you pick something out of the first run and say, let's pick that, or did you just pick something arbitrarily?
Just pick something.
Okay. So what'd you pick?
The probability of black card.
Black card. All right. So what's the probability? 50%?
Yes, sir.
Mayberry probability is equal to 50, or 0.5 probability. Sorry. And what would the physical probability be?
0.3.
Came out to be 0.3. Equal or not equal? Not equal. What about your last one?
We did the probability of an odd number.
Probability of odd. And the Mayberry probability would be,
0.38.
okay, thank you. Mayberry probability is 0.38. And what did you get?
0.4.
Wow, that's very unusual. Approximate, but not equal. All right, how about your die? What was your first number?
4.
And that physical probability is 0.16. What did you get?
0.2.
And most of your numbers are going to come out like this. Because most of the time, you ever heard the old saying, a blind pig finds an acorn every now and then? Or a clock, a damaged clock is right 2 times out of the day. You ever heard that? Well, you can say that a lot with the die. Sometimes a lot of your readings are going to be around 0.2. Especially if you just roll it 10 times. All right? So what was your second? Did you pick a number? Did a number show up in that run and you say, well, let's pick that number? So y'all just didn't follow any of my directions. What was your next number?
We did even numbers.
Even. So that's 0.5. And what did it come out to be?
0.5.
That usually comes out about when you do odd or even numbers with the, remember me telling you the 2 times 0.2? If you take that probability and actually calculate it in, it's very easy to get 0.5 on the even or the odd. Okay? And what was your last one?
The probability of rolling a 5.
Probability of rolling a 5. Well, that'd be 0.16. What did it come out to be?
0.3.
0.3. Again, here is one number, and you see that there's a little bit of a difference between those two, and it's still one number. All right, let's go with one more. Let's go with the expedient crew back here. Or did y'all ever finish? Okay. All right. I'm not worried about their randomability because they shuffled it 15 times between draws. All right. What was your first card that you picked?
3.
And that is a 4. So what's 4 out of 52? What's 4 out of 52? So calculator drill team. Huh?
0.07.
Okay, that's good. All right. Now, what did you actually get with that 3?
We got none.
Well, y'all are losers. All right. Good. All right. All right. Next one. What did you pick?
You picked the diamonds because they were very.
You got a lot of diamonds in this group?
Diamonds, yes.
Okay. So, diamonds, you're talking about 26 out of 52, which would be what? 0.5, right?
Actually 13.
No, 13 out of 52, which is what? Point what?
0.25.
All right. What did you actually get after you've seen a lot of diamonds in the first draw?
We actually got 5 out of 10.
So you got 0.5.
Apparently not that good shuffle.
Yes, that's what I was fixing to bring up. Even though they did shuffle 2 or 3 times, that shows that why do the Las Vegas casinos use the card shufflers? Because the card shufflers must be better, and that proves it right there. Okay. Huh? Let's say you're talking about a different shuffler. Nothing against the shuffler, but it all depends on how many, you know, when you shuffle, you know, you can shuffle sometimes, yes, come on in whenever, that's fine. How's breakfast? How's that all? Is it good? You know, some shufflers, they actually shuffle and it goes, and then some shufflers, you know what I'm talking about? Okay, some shufflers can get every single card into the shuffle. Some shufflers don't. Some shufflers do it 2 or 3 times, but they don't do every single card. You know what I'm saying? So that may be it up here. But you see, what I'm fixing to show you is, when you see something like this, what should you do? You should say, wait a minute. That's what you should say. Because why? Because what have you seen with all of these trials? The Mayberry probability is usually higher than the what? Than the physical probability. When you see the physical probability overtake the Mayberry probability, then what do you say? Something's up. Not necessarily cheating, but something is there to be what? Questioned. Okay? Now, what about your last one?
We decided to do face cards for no.
Face cards. And we said that was, face cards was 12 out of 52, which was what? Point what? 0.23. What was your actual physical probability?
0.20.
See? Now that one is normal. You wouldn't question that because that's normal. But if you've got a 0.5, then we would say, okay, there is a problem with the shuffling here. Okay? Whether it be a person or whether it be a card. You see what I'm saying? I mean, a machine. Okay?
We were also picking at random, not just from one location. We were, spreading it out, just randomly picking it.
Okay.
Could have been.
It could have something to do with it also. All right. Let's go with your die. What was your die? Probability of what number first?
6.
And what did you come out with?
0.2.
And you see that number reoccurring again because of the 2 sides, basically. All right. I'm sorry. Binary sides. All right. What was your next number? Now, did you see a number there and you picked it or what? You just picked out of the blue?
Yeah, we just went down. So we did 5.
5, and what was it?
0.2.
And 6?
2.
Oh, 2, I'm sorry. 0.16, what'd you get?
0.
That's unusual. Now, again, this, just like this, well, this one's not as bad. This one's not as bad because you got 0.07. But that right there is not unusual, but it's questionable because you got 0, and it should be 0.2 or 0.16 or whatever. So that's just, you can't question it. You can't, the die is less questionable than the shuffle. Okay? The shuffler, or the shuffle, not the shuffler, the shuffle. Because the shuffle cannot be as random as the die. And you have to think outside the box there a little bit. Okay? Let's go with the other 2 groups, or the other 3 groups. Let's just go ahead and finish out the class. That way everybody can have an easy day today. All right? Let's go with the back one back here. Well, let's see. This one, let's go with this one. What was y'all's first card?
Ace.
I'm just gonna write down the Mayberry probability, and it's the physical. What was your physical probability?
0.
You got 0 again. Okay, just like the other group. What was your second card? Queen?
Yeah.
Okay, what was that physical probability?
0.1.
0.1. And what was the last card?
3.
And what was that?
0.
0. Again, you're all talking about 4 out of 52, which is what? 0.07? All right, now we're going to talk about odds here in just a minute, and that's going to play, and y'all just remember that. Probability of what number first?
1.
What'd you get?
3.
0.3. Second number?
6.
6. What'd you get?
0.
0?
An odd.
Huh?
An odd.
Odd. 0.5. What'd you get?
0.4.
0.3?
4.
0.4. That's normal. Okay? 0.5, 0.4, that's normal. If you threw 10 rolls and you were looking for odd or even and it came out to be 0, would that be questionable? That would be very questionable. Why would it be very questionable?
There's no way to get a 0.
There is no way not to hit an odd or even if you say you're doing odd. And you roll a die and you hit every single one that's even, somebody's loaded that die. Okay? Now, why in the world would you be looking at stuff like this? Well, what if your income was gambling? Would you be looking at stuff like this? Yes. And there's some people that make their living by gambling. If they suck at it, then they need to change profession. But if they don't suck at it, then it's okay. All right, what about this group? First group on the left side. What'd you pick for your first card?
Diamonds.
Diamonds. And what was your physical probability?
0.2.
0.2. What's 13 out of 52? What does that come out to be?
0.25.
Okay, so that's about right. All right, what's your second card?
Spades.
Spades. What did it come out to be?
0.1.
0.1 versus 0.2 something. Remember? I'll just sell 13 out of 52. What was your last card?
Clubs.
Clubs. What was it?
0.1.
0.1 again versus 0.2. Okay, what is it? 0.25?
Yeah.
Okay, 0.25, 0.2 versus 0.25. Okay, so if you're making a living out of gambling, they're about right. What if one of them came out to be 0? Questionable. What if one of them came out to be 0.5? Questionable. Okay? All right, what was your numbers? What was the first number? Say again?
3.
I'm sorry, 3?
Yeah.
And what did you come out with?
0.1.
Against 0.16. All right, what was your second number?
1.
And what did you come out with?
0.2.
Against 0.16. And then the last one?
2.
2. And what did you get?
0.2.
0.2. All right, last group in the back. What was y'all's first card?
We did odds first.
I'm sorry, I couldn't hear you.
Odds.
5. What'd you get for your physical probability?
Odd.
I did odds.
Odd, sorry. Odd. What'd you get for your physical probability? 0.5. Questionable? No. Why? Because that's not what it's supposed to be. All right, what's the second one?
We did 3.
And what'd you get?
0.2.
0.2 versus what? 0.07. Okay, what's the last one?
We did aces.
8?
Ace.
Ace. All right, what did you get?
0.2.
Both of these are 0.07. So that's pretty good. Okay, it's not questionable, but it does raise an eyebrow because it should be 0.07. So it should be around 0.1. So that's, again, that could be the shuffling. It could be the way that you picked it if you had the same person picked it. And these are just questions that you would bring up, with a probability prediction. If somebody is sitting there telling you that I can predict without a shadow of a doubt, then you're going to sit there and ask questions, especially if you're going to put money on it. Okay? What was your numbers?
We did 4 first.
4, and what'd you get?
0.4.
Wow. 4.4? That's interesting. Now, let me ask you something. When you threw the die, did you throw it in the same place, or did it fall on the floor, or did you have it confined? Okay. Versus, I think y'all fell on the floor a couple of times. Okay, which one's more random? This one. Okay? Because if you have it in a contained area, it's kind of like the standard deviation. if you contain the area of the die, what's that going to do to the probability? It's going to affect it. All right? So, that's the first thing I would question versus what? That's my first question. Notice I didn't say anything about the die being loaded this time. Why?
It's not over half.
Because it's not over half, mainly because when you see something over half, that is a big indicator, unless it's supposed to be half. All right? The point forward, notice I didn't say anything about the die because the die, unless it's tampered with, the die is not going to be questioned. All right? What's going to be questioned then, if it's not loaded, the only thing that's questioned is the area and the way that it's being thrown. Like if it's being thrown against a wall or something, or it's being thrown, on the table and letting it fall, or throwing it on this table and, having, what do you call them things that you bowl with? Bumpers. Yeah, having bumpers on the side where it won't fall off. Is that containment? Yes. So if you contain the die at all, then it's going to probably affect it versus being loaded. All right, what's the other two numbers that you picked?
We did 1.
1?
Yeah.
And what'd you get?
0.
0, which is normal because these two are kind of close. And what's the last number?
We did even.
Even, and that should be 0.5. What'd you get?
We got 0.6.
Okay. Again, that's not loaded, but that tells me that there's a containment thing, that you're throwing it in one little area. Okay, now, what did y'all notice about all of these, most of them, I'd say 90% of them, you could say that the Mayberry probability, you don't write it like that. You would say that the physical probability does not equal what? The mathematical or the Mayberry probability, theoretical probability. All right? Did I tell you about the quarters? Okay. And the large number rule. The more times you apply the roll or the shuffle or the pick in the shuffle or whatever you want to call it, the more times you do the actual trial, okay, not 10, let's say you do 100 times, okay? If you did it 100 times, those numbers would be a whole lot closer and more what? Accurate versus 10 times. All right? Now, let's talk about the odds against. Does anybody know the formula for odds against? Now, when you do the odds against, you always want to leave them in fraction form. Does anybody know why?
No.
Good. That's the way you answer a yes or no question, either yes or no. All right? The reason is called interaction. Some of y'all might have heard of it before, interaction. The reason you leave it as a fraction is because the math is a whole lot easier. Because you're going to put a fraction over a fraction, and the denominators basically do what? Cancel out. All right? So if you try to do decimals because you're from the calculator drill team in high school, then you may run into a problem. It's the probability of failure against the probability of what? The complement of failure is success or not failure. It doesn't matter here because it's in a 50-50 trial. Okay? Now, what is probability of success? It depends on what the question is what? It's asking. Let me make up a question. What is the probability of you pulling a king out of a deck of cards? Okay, immediately you say to yourself, the question is saying that pulling out a king is success. Write that down. Pulling out a king is success. If I asked you, what is the probability of pulling a king out of a deck of cards? You automatically highlight that probability of king and you say that is success. That is P of S. The question will tell you what is your success. You will then say, what is the probability of what? The complement of success?
Yeah.
Failure. Now once you get those two fractions, It's real simple. So let's say that the probability of success is 4 out of what? Then the probability of failure is what?
40.
Which is the what? C-O-M, complement. Now, do that math. Divide by a fraction, you multiply by the what? Reciprocal. So that would be multiplied by 52 over what? And what happens to the denominator? That's what should happen. What? Huh? Yeah. So the odds against 12 to what? 12 to 1. Or 12 over 1. Okay, 12 to 1. Now it's important that you understand about odds against. And it's not that everybody's going to go to Las Vegas and start gambling tomorrow. That's not what it's for. You need to understand how to use odds against, because if I tell you I bet $75, some of you would have no idea how much money to win, and you have the answer staring you right in the face. Okay? Because you don't know how to use it. All right? So I'm going to show you how to use it. We'll go back to this screen in just a second. Let's say that I'm going to make a dozen cookies. And most of you, unless you're like the person that I drove up to the drive-thru one time and said, I want a couple of cheeseburgers, or was that a Hardee's? And I said, I want a couple of cheeseburgers. How many? I said, a couple. And they said, how many is that? Did I respond? No. Did I leave? Yes. I'm not going to give an order to an idiot. All right? What is a couple? Well, how many gets married in a couple? 1, 2. All right? I'm sorry. Now, if I say several, then yes, you have a question there. But if I say couple, please don't ask me what a couple is, especially when people get married and they're called a what? A couple. Okay. Everybody knows what a dozen is, I hope. I hope that's an SAT word or ACT word. All right? It's 12, right? Okay. What's a baker's dozen?
13.
Good job. Wow, I'm impressed. I figured it wasn't politically correct. Y'all wouldn't know it. Okay, so a dozen. Let's say 1 cup of flour, 2 eggs. I'm making this up, so these culinary people out here, shut up. I don't know what goes into a cookie, okay? So just hush, all right? I don't think, people have some shut up. All right, 1 tablespoon of butter, 1 cup of sugar, and 1 shot of liquor. Okay, so you got to have some fun in there somewhere. All right, now let's say you go through it. Somebody, he said liquor in class. Let's say that you want to make 2 dozen. Now, what if you want to make 2 dozen? What do you do with the? Okay, where'd you get the 2 from? Nope, not 2 dozen. Well, yeah, you do. With this particular number, you do. But where do you get the 2 from? How about the number desired over the number makes? The number desired is 24, right? That was your second call. 24, and how many is the number it makes? And what's 24 over 2? 24 over 12. And that is what's called the multiplier. So what if I wanted to make 36 cookies? Multiply everything by 3. What if I wanted to make 57.25? Then I'm weird. No, if you wanted to make 57.25, all right, calculator drill team. If I wanted to make 57 cookies, divide by 12, calculator drill team, what does that come out to be? 57 divided by 12. Y'all suck.
It's 4.75.
What?
4.75.
So you would multiply each one of those ingredients by what?
4.7.
And this is called the what? Any of y'all ever taken a science class in high school and your science teacher called it a fudge factor? Anybody ever heard that before? It's the number K. You ever heard of K being a constant? It's the number that makes the formula what? Work. Okay, in science, especially physics. Any of you ever take heat and sound, electricity physics 2 and 3? You're going to see a lot of fudge factors because when you're dealing with electricity and sound and time, you know, that third dimension of time, you've got to throw in a multiplier. Staying on the differential equation. All right, you guys throw in that multiplier. Now, let's go back to the original equation. Let's go back to the original question, which is, that's your multiplier. So if I bet $100, if I bet you $100, you shuffle the cards, and I bet you $100 that when I pick a card, it's going to be a face card, what will I win if I pick a face card out?
$1,200.
$1,200. Wow. Why? Well,
Yeah.
let's look at these probabilities. Somebody take 4 and divide by 52. What did we say that was? 0.07? I don't know. Is it? That's 7 cents out of $1. What is 7 cents out of $1 to y'all? To everybody. Very what? Very little. So let's make a correlation or causality. What is this probability? If the probability is very small, then that means the odds against are very what? Very high. Thus, we have okay. Las Vegas and the bank are not in the philanthropy business. Okay? What happens if you count cards in Vegas? You get beat. Somebody gonna take you into a closet with a man full of rings on his fingers. Alright? Okay, or you gonna have cement shoes. They gonna do something. They're not gonna let you sit there and do what? Win all night. So, if you go to a table, if you go to a card table, and the odds of winning are 15 to 1, then you throw your dollar down, you could easily win $15. But what's the probability of that happening? Very low. Versus if you go to the nickel slots, the nickel slots, you put in nickel, is Vegas bringing in a lot of money by bringing in a nickel? Yes or no? No. No. So the probability of winning is going to be very what? High. If they bring in money, the probability is going to be very low. If they don't bring in money, the probability is going to be very what of winning? Very high of winning. Okay? Some of y'all may remember the poker machines that used to be in South Carolina. I'm glad they're gone because they were crack cocaine to some people. Okay? Some of those things you could put in a nickel. And you won like every other time, but what would you win? 10 cents. Okay? You put in $1, the probability would go down. But if you won, you'd win $10. And then there was some that came out that would only take $5 bills. Okay? And those $5, the probability of winning went what? Down. But the odds against, if you won, instead of $10, you'd win what? $25 or $50. You see the trap? The trap is to get you started with the nickel slots. And then what will you progress to? The quarter slots. And then you'll progress to the what? Dollar slots. And then you'll progress to the $100 slots. Okay? There's one thing that gambling, drugs, and cigarette companies have in common. They bait you. They bait you, and then they what? They reel you in. So remember that. Remember, probability is low, the odds against are what? High, meaning the payoff is high. We'll continue this Thursday. Make sure everybody's here Thursday.
He doesn't want us to show up.
I ain't said anything, but you better check your email.